Assalamu alaikum. I hope all of you will be quite fine. This video is relevant to the article 2.7, the number synthesis. Synthesis actually is the process of determining the count or number of different types of links. For example, binary links, ternary links, quaternary links, or further higher order links, and their number or count for a specific DOF. So this is the process of number synthesis. So this article has well been explained in the class, but some important missing concepts that I would like to explain in this video. So we are all familiar that with this hypothesis that if all joints are full joints, an odd number of DOF requires an even number of links and vice versa. Means if DOF is odd, then the number of links must be even, and vice versa. Means if the number of links are odd, then the DOF must be even. So in this way all these things have been explained while in the class. So here important are two equations. This equation 2.4a, which actually adds up various types of links, means binary, ternary, quaternary. Remember that B means the count of binary links in a mechanism, T means the count of ternary links in a mechanism. So it is actually the count or number of certain types of links. So when certain types of links will be added up, so they will be giving the total number of links, which has been denoted by letter L. So in a similar manner, for this analysis we must remember these two equations, 2.4a and 2.6. so these two equations are the decision making and final equations which will be used for the synthesis process. So the author has actually explained here for one DOF system and up to 8 links. So for the assistance of the students and to make them better understand, I had asked and suggested the students while in the class that they will be performing the process for L is equal to 10, means 10 number of links. So I can add a further case number 5 here, and I will be explaining this tabular approach here in this way. So the number synthesis for 1 DF and L is equal to 10 up to hexagonal order. So this tabular approach is very interesting and simpler, and student must be well conversant with this technique, and so they should be able to do the number synthesis using this technique. So tabular approach for M means DOF is equal to 1 and L is equal to 10. So this is the basic equation which is equation 2.6, L minus 3 minus M. So M is here is 1, as we can observe here if we refer the equation here. This equation 2.6 means DOF is 1, so L minus 3 minus 1 means L minus 4. So in this way, this equations T plus 2Q plus 3P plus 4H. So if total number of links are 10, so 10 minus 4, this will come out to be 6. So here 6 is written. So the other equation that is used, that is equation 2.4a here, which actually connects certain types of links into total number of links. So the second equation is written below. So these are two basic equations. So to start the analysis, as it has been suggested, that we will always be starting from the highest order link. Highest order links means here the highest order link is hexagonal because it has 6 nodes. So the highest order link is hexagonal link, and highest order and its lowest count means we will be starting from 0 and 1 and will proceed further if greater than 1, 2, 3 and 4 in this way. So for every synthesis process we will be starting from the highest order links uh, up to hexagonal. So and we will be starting from its lowest count. So its lowest count, one is h0 and other is h is equal to 1. So there are two binary values means h0 and h1. So we will be starting from these values. So if for example we can for say h is equal to 1 in this equation, this set of equation, so we will first of all be putting h is equal to 1 into the first or upper equation. So when we put h is equal to 1, we observe that the result will be t plus 2q plus 3p plus 4. So on the right hand side there is 6, so 6 minus 4, this will come out to be 2 here. So on the left hand side there will be t plus 2q plus 3p. So this will be equal to 2, and the same h that will be used in this lower equation of total number of links. So this will be reduced to b plus t plus q plus p is equal to 9 because 10 minus 1 hexagonal link will be subtracted, and so this equation will be resulting. And after that we will be starting the same procedure from this set of equation, that we will be starting from the highest order link and its lowest count. So in this equation the highest order link is pentagonal or pentanary link, and its lowest count can be 0 or 1, but as we observe that if p is equal to 1, so the result will be t plus 2q plus 3 is equal to 2. So on the right hand side there is 2, so when 3 will be subtracted from 2, the result will be minus 1 on the right hand side. So that means we will be requiring some negative number of links to give the negative result, so that is impossible. So we can't take p is equal to 1, so that means p must necessarily be equal to 0. P must necessarily be equal to 0. So when p is equal to 0, the equation are resulting here like this, that t plus 2q will be equal to 2, and the lower equation will be reduced to b plus t plus q plus p is equal to 0. So b plus t plus q is equal to 9 in this way. So when we have approached up to this stage, now we can say that t plus 2q is equal to 2, and here again we will be repeating the same procedure, that we will be starting from the highest order link and its lowest count. So in this equation the highest order link is quaternary link. So here we can observe that this quaternary link can assume or adopt two values, q is equal to 0 and q is equal to 1 only, because if q is equal to 2 for example, though here it will be 2 multiplied by 2 4, so t plus 4 is equal to 2 means 2 minus 4 will be minus 2. so that means the ternary links will become -2, so which is impossible. So that means only there are two possible and correct values, which is q is equal to 0 and q is equal to 1. So that means if q is equal to 0, that means t is equal to 2, means if quaternary links are 0, then there must be two ternary links for this case. So the lower equation will give that q is equal to 0 and t is equal to 2, so 9 minus 2 will be 7, so binary link will be 7 and ternary link will be 2. Ternary links will be 2. So here like this, one set will be obtained, means binary 7, ternary 2 and hexagonal 1. So 7 plus 2 plus 1, which is equal to 10. So one set for hexagonal link. If hexagonal link is 1, so first set has been obtained. 7, binary 7, ternary 2 and hexagonal 1. So in this way first set has been obtained. The second set, we can observe that if q is equal to 1 in this equation, so that means t plus 2 is equal to 2, that means 2 minus 2 is equal to 0, so ternary links are 0. So here t is equal to 0, and in the lower equation will give that q is equal to 0 and t is q is equal to 1, so that means 9 minus 1 8 and t is equal to 0, so binary links will be 8. So the second set will be obtained, binary 8 links, quaternary 1 link and hexagonal 1 link. So 8 plus 1 plus 1, so this comes out to be total number of links, which are 10. So in this way two sets have been obtained. Now we approach to the other binary value of hexagonal link, which is 0. So if we put 0 in this set of equations, the above equation of the upper equation gives that t plus 2q plus 3p is equal to 6, and the lower equation will be reduced to b t plus q plus p is equal to 10. So again we will be repeating the same procedure, that here are two sets of equations, t plus 2q plus 3p is equal to 6, and the other equation is b plus t plus q plus p is equal to 10. So here again we will be starting from the highest order number of links and its lowest count. So the highest order number of link is here pentagonal link, and it's the value it can assume here are written, that p is equal to 0, p is equal to 1 and p is equal to 2. So p can assume or adopt only these three values, because if p is equal to 3, that means 3 multiplied by 3, so here will become 2 plus t plus 2q plus 9. So when 9 will be subtracted from this 6 on the right hand side, 6 minus 9, so here the result will be t plus 2q is equal to minus 3. So that will be requiring the negative number of links, either ternary or quaternary link, so which is impossible state. So that means it can assume or adopt only these values, p0, p1 or p2, these are valid values. So in this way, so if p is equal to 0 in this equation, this set of equation will be reduced, t plus 2q is equal to 6, and the lower equation will become b plus t plus q is equal to 10. So here again we first solve for p is equal to 0 case. So t plus 2q is equal to 6, that means the quaternary link in this set of equation can assume these four values, 0, 1, 2 and 3, because all these values are possible. But as stated earlier and explained earlier, that q can't be greater than 3, because if q is equal to 4, here will become 2 multiplied by 4 means t plus 8, and when this 8 will be subtracted on the right hand side from this 6, so 6 minus 8, that will be minus 2, means t will be equal to minus 2, means negative ternary link, so which is impossible. So that means only these values are valid for the quaternary link. And why we started from the quaternary link? Because in this set of equations of ternary and quaternary set, the quaternary link is the highest order link. So when q is equal to 0, we observe that t is equal to 6 here, and the lower equation will give q is equal to 0 and t is equal to 6, so 10 minus 6 will be binary will be 4. So the third set we can say, because this was the first set, this was second set, so the third set we can say that will be binary 4, ternary 6. So 6 plus 4 is equal to 10, so hence the total count of link has been satisfied. Again, if q is equal to 1, so in this equation t plus 2 is equal to 6, so 6 minus 2, t is equal to 4, so t is equal to 4, and the lower equation will give that q is equal to 1 and t is equal to 4. That means 4 plus 5, so 10 minus 5, binary link will be 5. So here binary links will be 5, ternary links will be 4, and quaternary link will be 1, so 5 plus 4 plus 1. So in this way total number of links 10 has been satisfied again. And when q is equal to 2, here we observe that 2 plus 2 multiplied by 2, 4, t plus 4 is equal to 6, so 6 minus 4, t is equal to 2, so that means t is equal to 2, and the lower equation will give in a similar manner q is equal to 2 and ternary is equal to 2, so 2 plus 2 4, so 10 minus 4, b is equal to 6, so here binary will be 6, ternary 2 and quaternary 2, so 6 plus 2 plus 2 is equal to 10, so hence the count of total number of links has been satisfied in this set as well. So in this way first, second, third, fourth and fifth set has been obtained. Now we will be using q is equal to 3, and as we can observe 2 multiplied by 3 is equal to 6, t plus 6 is equal to 6, that means t is equal to 0, so t is equal to 0, and the lower equation will give that 0 plus coordinate links are 3, so 10 minus 3 is 7, so b is equal to 7, b 7 and plus 3, so in this way total count of 10 links has been satisfied. So in this way the sixth set has also been obtained. So first set, second set, third, fourth, fifth and sixth, 6 sets have been obtained. Now we proceed to the other value, that is p is equal to 1. So again we will be starting from this equation, because h0 gave this set of two equations, so p is equal to 1, and we can observe that if p is equal to 1, the equation, this set of equation will be reduced to t plus 2q plus 3 is equal to 6, so 6 minus 3 is equal to 3, so t plus 2q will be equal to 3, and the lower equation will be that p is equal to 1, so 10 minus 1 will be 9, so b plus t plus q is equal to 9 in this way. In this way, so again we will be repeating the same procedure, that in this set of equation we will be starting from the highest order link, which is quaternary link. So it can adopt only two values, q is equal to 0 and q is equal to 1. As we can observe that q cannot be greater than 1, because if for example q is equal to 2, so that means 2 multiplied by 2 will be 4, so t plus 4 is equal to 3. That means 3 minus 4 will be equal to minus 1, so t will be equal to minus 1, which is impossible because none of the links can adopt or assume a negative value. Links are always physical links and they are a positive count, so that means their value cannot be negative in any case. So in this way, when q is equal to 0, we observe that t will be 3 and the lower equation will be giving that 9 minus 3 is equal to 6. So the seventh set will be binary 6 links, ternary 3 links, and pentagonal 1 link. So 6 plus 3 plus 1 will be equal to 10, and in this way seventh set will also be obtained. And the other value for quaternary link in this from this equation is 1. So when q is equal to 1, that means t plus 2 is equal to 3, and 3 minus 2, that t will be equal to 1. So in this way t is equal to 1, and the lower equation will give that 1 and plus 1 2. So 9 minus 2 7, so binary link will be 7. So in this way the eighth set will be binary links will be 7, ternary link will be 1, and quaternary link will be 1, and pentagonal link will be 1. So 7 plus 1 plus 1 plus 1, 7 plus 3 is equal to 10. So in this way eighth set will also be obtained. So now we proceed to the last value of p, which is equal to 2 for the hexagonal 0 case. And as we can observe that when p is equal to 2, we observe that 3 multiplied by 2 will be 6. That means t plus 2q is equal to t plus 2q plus 6 is equal to 6. That means 6 minus 6 0. So t plus 2q will be equal to 0, and the lower equation will be reducing to b plus t plus q is equal to 10 minus 2 8, means pentagonal links are 2. So as we can observe, the equations will be reduced to t plus 2q is equal to 0, and the lower equation will be reduced to b plus t plus q is equal to 8 in this way. So that means if we observe this upper equation t plus 2q is equal to 0, we observe that none of the t and q can obtain or can adopt other value than 0. Means both t and q must be 0, because none of them can obtain any value other than 0, because on the right hand side there is 0. So that means t is also 0 and q is also 0. So that means t is equal to q is equal to 0, and the lower equation will simply giving b is equal to 8. So in this way binary links will be 8 and pentagonal link will be 2. So 8 plus 2 is equal to 10, and in this way the ninth and the last set has been obtained and satisfied. So now we observe that this table, because in this table, as we can observe here, in this table link number up to 8 links, this table was actually available in the book. This table is available in the book, but now I have added the link count up to 10. So this 9 set 1 2 3 4 5 6 7 8 9, so these 9 sets value has been registered here. So in this way, and here we can observe I have added one last column which is n by 2. And what is n by 2? Actually these 1 2 3 and 4, these 4 columns have been added for further explanation, because here in this table actually number synthesis is giving actually only the possible sets of links, but it is still the decision of the designer and some principle that whether these links, these sets of links will be able to be connected or not. So here is a statement that we can observe from the book uh, in the article of isomerism, article 2.9, and here he has written that here this statement that the highest order link in a linkage cannot have more nodes, uh, cannot have more nodes. The highest order link in a linkage cannot have more nodes than n by 2, where n is the total number of links in that linkage. So that means if the highest order link, for example there is a hexagonal link and the hexagonal link has 6 nodes, so that means if there are for example total 10 number of links, then n by 2 will be equal to 5. So the as we can observe that if there is at least one link of hexagonal order, that means there are 6 nodes. As 6 is greater than 5, so that means that is an invalid set which is practically unable to be connected to obtain the mechanism. So we must be careful with this fact. So to satisfy this fact, I have added these columns, and as we can observe that in the previous table which is available in the book up to 8 links, we observe that this third line, as we can observe here, the highest order link is quaternary link. Highest order link is quaternary link. So quaternary link has 4 nodes. Quaternary link has 4 nodes, but total number of links means n are 6 links. So 6 divided by 2, so this comes out 3. So that means the highest order nodes are 4, so 4 is greater than 3. That means that is an invalid linkage or invalid set which practically or physically cannot be connected to 100% nodes. So we must observe this fact while applying the number synthesis. Once the number synthesis has been applied, after that we will be noting or recording this fact. In a similar manner, this fourth line, we can observe that here the highest order link is hexagonal link which has 6 nodes, but the total number of links are 8. So n by 2 is equal to 4, so 6 is greater than 4. That means also this set is also invalid. And in a similar manner, this last row we can observe here also there is one pentagonal link, and pentagonal link has 5 nodes. Pentagonal links has 5 nodes. So here mistakenly I have written 6, and here must be 5. So here we can observe that 5 is greater than 4. So here mistakenly typing, there is a typing mistake. So here must be 5 must be greater 5 is greater than 4, so that is also an invalid set like this. So when we approach to this 10 number of link sets, we observe that this set here, when binary links are 7 and this quadrant links are 3 and hexagonal link is equal to 1, means 7 plus 3 and 10, because there is a hexagonal link and hexagonal link has 6 nodes and the total number of links are 10. That means n by 2 is equal to 5. So 6 is greater than 5. That means that is also an invalid set which is not physically connectable. In a similar manner, as we observe that here in this set, we observe that bind links are 8 and quadrant link is 1 and hexagonal link is 1, and again hexagonal link has 6 nodes, and here in again 6 is greater than 5, so this is also invalid set. So all these hexagonal links sets are invalid. So in this way these columns have been added. So after performing the number synthesis, we after performing the number synthesis, we must also note this fact while tabulating the values, that whether the link sets are valid or invalid. So if you have any question, you can ask. Thank you and assalamu alaikum. Further for 3 and 4 DOF I will be explaining in a later video.